This is question 2. I am going to start by reading the question and underlying all the key terms, and I will explain why I consider these key terms. So a sample, all right, a sample is probably not really important at this point, of hydrogen gas. So I'm going to start with hydrogen gas. There are a few reasons why this is a key term. First of all, if you're given hydrogen gas, you should be able to determine the molecular formula of the gas. This is a diatomic gas, so it's H2G. It's always a good idea to do this because you never know when you need to work out the mass. The other piece of information that this term gives you is that this is a gas. And because it is a gas, you are allowed to use the universal gas law. Every gas, assuming ideal behavior, its behavior can be described using universal gas law. So I know that PV equal to nRT for this gas. You can find this formula from the data book. And I think the most important thing to remember when you use the universal gas law is that you need to have a gas in order to use it. More often than not, students, especially when they don't read the question carefully enough, will just use this formula even when you have a solution, and that is definitely inaccurate. Okay, so I have hydrogen, I have gas, and then I have a sealed container. This is a very important term, I guess. First of all, you have a container, so the gas is in some sort of jar. I don't know why I need to explain the word container, but the word sealed is actually the key word here. If the container is sealed, all right, sealed container. If the container is sealed, it actually means that the number of mole is constant because gas cannot escape if the container is sealed, and that is the assumption that you're allowed to make here. So number of mole is constant, and the volume of the gas is also constant. That's generally what a sealed container means. Okay, so you really need to make sure you understand these words in the question. They are there for a reason. You really want to read the question carefully. Next keyword I would say is pressure, which is a term describing the force the gas in this case applies onto the wall of the containers. And I am going to write the symbol for pressure is capital P. Kilopascal is the unit of pressure in this case. It's one of the many different units that you also given 20 Celsius degree. This is temperature, and it is right now in Celsius degree. When the temperature is raised by 20 Celsius degrees, so the word temperature also appears, and the question asks for the pressure. So I think I have identified all key terms and explained them. The next thing I'm going to do is I am going to write down what is given and what I need to find. And maybe I can identify what additional information I need. Okay, so you given, essentially what's happening here is you start with a sealed container. It starts at a pressure of 48 kilopascal and a temperature of 20 Celsius degree. The temperature is then increased by 20 Celsius degrees. So this is a situation when you start with some physical quantities and you end with some other physical quantities. So there is an initial condition or situation, and initially the pressure, now you can go with P0, Pi, I'm going with P1 here, but you really want to distinguish between the different pressure and temperature quantities in this case. So the initial pressure is 48 kilopascal. The initial temperature is 20 Celsius degree. And final, so afterwards, the temperature is increased by 20 Celsius degrees. So the final temperature, I'm indicating that as T2, is going to be 40 Celsius degree. You need to find the final pressure. Okay, now the question is there a relationship between P1, T1, T2, and then P2, which is the required information? And if you don't remember all the individual relationships, which are described by all the individual gas laws, you can derive all of them using the universal gas law. Okay, this is where number of mole and volume is going to come in. So if I have PV equals to nRT, one way to do it, I guess, is to have all the provided quantities on one side. So this question is focusing on pressure and temperature. So I am going to move temperature to this side. So I have P over T, and everything else that is not provided in the question, I'm going to put on the other side. So from the universal gas law, I can change my equation into P over T equals to nRT, sorry, nR over V. All right. Now, because number of mole in this particular case is constant, since this is a sealed container, the volume is also constant because this is a sealed container, and R is already a constant, is the universal gas constant. We can safely establish that this ratio between pressure and temperature has to be a constant, which means that no matter how you change pressure and temperature, given that volume is constant, you're going to have the same ratio. And so that is the relationship between pressure and temperature. Another way of representing this is, so I'm just going to write out what I just said. No matter how you change the condition, the ratio between pressure and temperature will be the same, which means that P1 over T1, which is the ratio initially, is going to equal P2 over T2, which is the ratio finally. So this is the relationship between pressure and temperature. One more thing you're going to need to do, and I think this is probably the one thing that people forget most often, is this formula, which is the start of it all. You derive this relationship from this universal gas formula. This formula has a very specific set of units. So pressure in this formula, in order for this formula to make sense, pressure has to be in kilopascal, volume has to be in liter, and temperature has to be in Kelvin. So unless you have the units correctly, you cannot use this ratio, and it will change the constant if the temperature is not in Kelvin. My pressure, the one that's given to me anyway, is already in kilopascal, so what I have to do now is to convert temperature from 20 Celsius degree to kilopascal. And if you're not sure, check the data book, but you basically need to add 273. So I'm going to get 293 kilopascal. Did I just say kilopascal? Kelvin. And for this one, I'm going to get 313 Kelvin. So I've already converted the temperature to Kelvin now. I've got the relationship. I've got the correct units. My plan here is I need to find P2, and that shouldn't be too difficult. You just need to solve this equation. So if P1 T1 equal to P2 T2, then that stands to reason that P2, which is the unknown here, is going to be P1 over T1 times T2. Okay, so I think that's everything. I've got the correct units. Hopefully, I just need to do the calculation. All right, P1, so 48 over 293 times 313. Okay, 48 over 293 times 313. Whoa, what's happening? Syntax error. That's not good. I got 51.28. 51.28 kilopascal. Now that will be the unit for the pressure because that is the initial unit of P1, and since the unit of temperature will cancel out, you get kilopascal left. It is always a relief when your answer is actually one of the options provided. How else are we going to check the answer? Now, if you increase the temperature of a gas sample in a jar, then it stands to reason that the pressure will increase because the gas particles will move faster and they should exert more force onto the walls of the container. So the pressure should increase. So hopefully you can tell that the pressure is not going to be the same. It's definitely not decreasing. So it's either C or D, and by our calculation is C. I think this is a sensible answer. I think the unit is correct. So that's it. C.